Look up on a clear night and pick any point of light that isn't moving. It looks finished, fixed, permanent, the same star your grandparents saw, the same one their grandparents saw. It isn't. Every planet orbiting every one of those points is somewhere in a life cycle that started violently and eventually ends the same way. Astronomers have now confirmed more than 5,000 planets around other stars, and by every serious estimate, that number is a small fraction of what's actually out there. Most planets you could name are either still being assembled or already being unmade. Almost none of them get to just sit there, done. Start with how a planet actually gets built in the first place. The solar system you're standing in began as a flat disk of gas and dust circling a newborn sun. And inside that disk, grains of dust collided and stuck, over and over, building up from specks to boulders to full planets over a few million years. You don't have to take that timeline on faith. In 2002, geochemist Yuri Amelin and his team measured the lead isotopes locked inside tiny mineral grains called calcium-aluminum-rich inclusions, pulled from some of the oldest meteorites ever recovered, and calculated an age of 4,567,000,000 years. That number is now treated as time zero for the entire solar system. The moment the clock started on every planet in it, including the one you're standing on right now. But building a planet is not the same thing as keeping it. The disk a planet forms in is closer to a demolition derby than a nursery. Dozens of young protoplanets on crossing orbits, all tugging at each other's paths, and not every one of them survives to become a stable member of a solar system. The flinging isn't gentle. It usually takes a near miss with a much bigger neighbor. A young gas giant like Jupiter swinging close enough to slingshot a smaller world onto a path it can never return from. The same slingshot mechanics spacecraft use deliberately today, just violent, accidental, and permanent. Some worlds get thrown completely clear of their system before it even finishes settling down. That is the first way a planet can die without technically dying at all. It simply leaves. Astronomers can actually count these orphaned worlds using a technique called gravitational microlensing. When an invisible object passes almost exactly in front of a distant background star, its gravity briefly bends and brightens that star's light, like a lens swinging past. In 2011, the MOAA survey team, led by astronomer Takahiro Sumi, reported an excess of extremely short brightening events in their data, and concluded there might be roughly 2 Jupiter-sized, free-floating planets for every single star in the galaxy. It was a startling number, and not everyone believed it. Critics pointed out that no infrared survey of young star clusters had ever turned up nearly that many massive, orphaned worlds drifting nearby. The follow-up work bore the skeptics out. A 2017 study by astronomer P.R. Zemislaw Mróz, using a larger Ogle survey dataset, could only support a far smaller number of Jupiter mass rogues, and a 2023 reanalysis by Daisuke Koshimoto traced the original excess to a data processing error in how the telescope handled atmospheric refraction. The big, dramatic number didn't survive. But underneath that retraction, something smaller and just as strange did. Both later studies still turned up a real population of smaller, Earth-mass, free-floating planets, adrift with no star at all. The exact head count keeps changing. The existence of the planets doesn't. So some planets never even keep a star to begin with. The ones that do aren't safe either. Eventually, the star itself becomes the threat. Every sun-like star spends most of its life quietly fusing hydrogen, then swells late on into a red giant hundreds of times its original size. For a long time, the fate of a planet sitting at Earth's exact distance from a star like the Sun was treated as close to a coin flip. An influential 1993 model, built by astrophysicist Juliana Sackmann and her team, suggested Earth's orbit might actually widen enough, as the Sun sheds mass late in life, to escape being swallowed outright. Then in 2008, astronomers Klaus-Peter Schröder and Robert Smith reran the numbers with a far more careful model of tidal drag, the friction a planet feels skimming through the outer edge of a swollen star's atmosphere, and arrived at a different, more brutal answer. Earth's orbit does widen. It just doesn't widen fast enough. The drag wins first. In their model, the sun's expanding atmosphere catches Earth and swallows it whole, roughly 7.5 billion years from now. The math that was supposed to save the planet turned out to be the same math that dooms it. If a planet's own star doesn't grow enough to eat it directly, the star can still come back for it after it has already died. When a sun-like star finally burns through its fuel, it leaves behind a white dwarf, an Earth-sized ember of collapsed stellar core, still blisteringly hot, still gripped by intense gravity. For decades, astronomers had noticed something odd in the light of many white dwarfs. Their atmospheres were polluted with heavy elements like calcium and magnesium, elements that should have sunk out of sight within only a few thousand years under gravity that strong. And this wasn't a rare quirk. Across multiple independent surveys, astronomers have found that somewhere between a quarter and half of all white dwarfs studied show the same pollution. Something had to be feeding all of them fresh material, again and again, for as long as they'd existed. In 2015, a team led by astronomer Andrew Vanderburg finally caught the process directly, watching a single white dwarf called WD 1145 plus 17, 570 light-years away. Every 4.5 hours, something dimmed part of its light, not a planet exactly, but the shredded, disintegrating remains of one, a rocky body being torn apart by the white dwarf's gravity and streamed out behind it in a tail of dust, precisely the kind of debris that would explain the pollution. It was the first time anyone had caught a white dwarf in the act of consuming a planet, instead of just finding the aftermath scattered across its atmosphere. Here's the twist folded inside all of this. Death, for a planetary system, isn't always the end of the story. Sometimes it's the reset button. In 1992, astronomers Alexander Wolszczan and Schröder Frail announced the first confirmed planets ever found outside our solar system, and they weren't orbiting a star like the sun at all. They were orbiting a pulsar, the rapidly spinning, city-sized corpse left behind after a massive star detonates as a supernova. That explosion should have vaporized or flung away anything nearby. The two worlds Wolszczan and Frail found, each a few times the mass of Earth, almost certainly didn't survive the original blast. They're thought to have formed a second time, condensing out of the wreckage that fell back around the dead star afterward. Planets like this stay rare. Decades of searching since 1992 have only turned up a handful of confirmed pulsar planets total, against the thousands now known around ordinary stars. But rare isn't the same as impossible, and that's the point. The very first exoplanets ever confirmed to exist anywhere aren't survivors of anything. They're what a planetary system looks like after it quietly rebuilds itself out of its own funeral. So look up again. Every point of light up there is either an unfinished planet still being assembled out of a disk of dust, a planet already thrown out into the dark with no star left to call its own, one slowly being widened away from its star only to be caught by that very same expansion, a shredded ring of debris feeding a dead ember of a star that already killed it once, or, in a handful of strange systems, something built a second time from the wreckage of the first attempt. There is no version of a planet that simply gets to stay finished. Yours hasn't finished either. It's only further along than most, in a story that started 4.5 billion years ago and is, right now, still being written, one orbit at a time.